the surface of each step becomes simple. And therefore, it is an algorithm to compute. So, this scaling can be computed by algorithmic means. This kind of definition is there exists or does not exist. There is no algorithm for this. So this is extremely bad from the practical viewpoint. But there is a formula. Zero. Chi equals 2 minus 2 times the genes. So when we can compute this by an algebra, then I can use this also by an algebra. So the 1% missing is
now we also
the 1% missing is why I have to go.
okay, but for the two depends on what are the y2 is equal to 2. Okay, in my mind there is only diagonal theorem I learned. But if I have a surface made of faces, there is something like the number of this plus the number of that equals 2 plus the number of that.
That is, you should still keep remembering this. This is very good. But to prove that this, the meaning of this is more hidden, I need to develop for you something which looks like a wall. If I wish really to prove with this that they have something which is additive or is more difficult. Here you have one kind of piece, but the piece is very complicated. The piece was a triangle. And then you start adding triangles, but around the corner you can have many of them. So here, when we have pieces and they say glue together, the list of possibilities is extremely small. The D piece plus a 2 makes a D piece. The simplification, the grammar is very small. Here, the grammar is bigger. And then we should prove something, the story becomes longer. But this also has advantage. This approach is general for other topological spaces. The approach with D and cubes and so on is strictly adapted to surfaces. So for surfaces, I think it is better. But the general relation is by special decomposition. Instead of triangles, you could have pieces which are like this. But then you have very, very complicated things. If you have a pyramid, and you glue another one for below, then I can go from this point inside to that point. Then this thing, 2 pyramids glued together, appears as the union of 3 pyramids. Oh, it's the figure. If I do this, and I do this in the middle, then you see 3 pyramids. This line, which is, and the pen makes a pyramid. And this line and the pen makes a pyramid, and the other side also. So you see, 2 pyramids makes 3 pyramids. So 2 equal to 3. That is a catastrophe for those who like numbers. So the simplicial version to make this work is slightly less elegant than UDP's version of surfaces.
Okay, but when you go to higher dimensions,
we don't do this in this.
Another method.
No. We don't do this. We don't do this.
What I'm saying, if I remember properly, my memory is very bad, going through the Gauss-Bonnet theorem.
Gauss-Bonnet theorem I can do with cubes. I don't know this. Gauss is two-dimensional.
Or any dimension.
No, then you do not have Gauss Bonnet. Then you have something more fancy.
I still get simply multiply connected confused with genus. For example, what is the genus of a Riemann two-sphere with a hole at infinity and a hole at zero?
It's not the surface for me. I take only surface, so when you have holes, you have kind of hidden boundaries. Then of course there's a definition of genus. And then I need more pieces. So I strictly state that list of surfaces.
I guess that's part of my problem, so the Riemann sphere.
So I can also for you, if you have these holes, then fill in the holes by small distances. And then go to the genus that way. Then you get the answer. So it's still, but in the way I present it, I keep the most simple kind of surface. You go next, minus punctures or minus gaps, so fill in the function at this point. If it is this disk at this disk. Then you get the closed surface. Then compute genus according to this law. You get your genus.
All these poisons is in the Euclidean space.
But those space.
In any space?
It is on, no, if I say Euclidean space, means you have notion of measurement. We do not have notion of measurement. This is on the plane without any notion of measurement. No angles, no distance. It is on the topological plane.
But not in a Euclidean space.
Huh?
Not in a Minkowskian space-time.
It could be, because topological in the Minkowski space and the Bobolic space, they are all the same.
But in these spaces, you cannot close the book. So, you have closed the book.
Let's be clear. It's closure of surface. I do not go to get a good name for this. Let's take the French name, Cartesian plane. And then take the school notation for this. This is R2.
But all these reasonings, the characteristics and course, these curves are closed. You cannot close a curve in hyperbolic plane, in absolute plane.
What I do not understand. This deep piece.
Yes, but this is a Euclidean piece. In a
we have no measurement. Because as soon as we have measurement, then if I take a deep piece and add a gap, then it is not the same as this. As soon as I have the notion of length, and therefore topologically the same was by this definition, by a continuous map. And a continuous map can destroy measurement, can make small things longer and short things, long things shorter. So don't think that we have in this plane the notion of measurement. This comes later. This is hidden in the letter J. Then we go to the affine plane, to the Euclidean plane, to the sphere. We have all the planes which show up in the G. But at the moment, we do not have the measurement.
No, but I say that we depend on closed curves for making points. Closed curve, we cannot close the curve in a hyperbolic plane.
In hyperbolic plane, we have closed curves.
No, it's hyperbolic plane. This is Euclidean. No, not in the Lorentzian plane. In the Euclidean plane. Space-time. One space coordinate and one time coordinate. The teacher is working with and
there we have preferred coordinates. You have beginning of measurement. You have time, you say.
But the other characteristic depends on this closing course.
But you say we do not have closed curves because time goes on. We have nothing of this kind of thing in our plane. So this is just a plane without any measurement, without clock, without, of course, in our everyday life, what I say now, I can say tomorrow it is wrong. But I cannot also tomorrow forget. So this means we have time, and then...
Can you just say that this plane is not embedded, this surface is not embedded anywhere, and this will finish the...
Yes, a triangle surface are not embedded anywhere.
They exist for
This is just most technical language, so differential manifolds of dimension 2. I do not know time.
Okay, it's equal already to complicated coming into the area. You've done more than 1 hour, but this is not a conference.
Yeah, but I did half of what I wished to.
Oh, that's a problem.
Okay, thank you for your attention.